So what are the rules for assigning oxidation numbers? If you're dealing with an elemental substance, there's no reason why electrons would belong to one element. If you have any shared electrons, there's no reason why it would belong to one atom versus another, or they're all the same. So for an elemental substance, the oxidation number for all the atoms is 0. If you're dealing with compounds, okay, if the compound has monatomic ions, the oxidation number is just the charge. If it's made up of molecules or it has polyatomic ions, okay, then the rule is find the most electronegative atom and then assign it a negative oxidation number as if that particular atom is isoelectronic with the closest noble gas. So if you see a fluorine there, give it a -1. Fluorine is the most electronegative atom, right? So anytime you find fluorine in a compound, automatic, -1 oxidation number. Oxygen is usually -2 because that's the second most electronegative element. Oxygen gains 2 more electrons, becomes isoelectronic with a noble gas. Anytime oxygen bonds with another atom, it owns that shared electrons. So it ends up having 8, so 6 minus 8, 6 by itself, 8 in a noble gas-like configuration. Oxygen will have an oxidation number of -2. What's one exception? If it's combining with fluorine, right? Oxygen versus fluorine, fluorine wins. So OF2, for example, okay? What's the oxidation number of oxygen in OF2? Each fluorine is going to have an oxidation number of -1. Then the oxygen must have an oxidation number of +2. Okay, it's an important rule that oxidation numbers in a molecule or a polyatomic ion, they must all add up to the overall charge. So if you're dealing with a neutral molecule, all the oxidation numbers must add up to 0. Okay, halogens. What are the halogens? That's fluorine, chlorine, bromine, iodine. Okay, they're usually -1. They're among the most electronegative atoms. Okay, so you have to remember your electronegativities. You have to more or less know the sequence. All right, so let's apply that to this reaction. This is a redox reaction, okay? So what's reduced in this reaction? Which atom, which element? So you assign oxidation numbers. This is an elemental substance. What's the oxidation number of copper then? According to our rule, 0. Pure elemental substance, 0. How about HNO3? All right, HNO. Oxygen is usually what? -2, right? So -2 times 3, that's -6. Oh, I forgot something about hydrogen. Hydrogen, okay, it's usually +1 if it's among nonmetals, if it's sharing electrons with nonmetals. You'll notice hydrogen is one. Among the nonmetals, hydrogen is the least electronegative, okay? But if it's combining with a metal, for example, in the AlH4, aluminum hydride ion, okay, it's bonded to an aluminum atom, okay, and the overall charge is negative, then the hydrogen has a -1 formal charge. Why? Hydrogen, to be isoelectronic with the nearest noble gas, just needs 1 more electron, right? So you need 1 more electron to add to that to make it helium-like. So hydride has a -1 oxidation number. Okay. So hydrogen in this case is 1 +1. So what's our nitrogen then? Well, let's call that X. This whole thing should add up to what? That should not be, that's not +1. That's not +6. It's +1 for the hydrogen, plus X for the nitrogen, plus -6 for the 3 oxygens. Together, they should add up to 0, right? So what's the oxidation number of nitrogen? +5. Okay, so the oxidation numbers here are +1. Let me do this. Hydrogen is +1, nitrogen is +5, oxygen is -2. What about NO? Oxygen? What is it? Second most electronegative. We don't have a fluorine there, so oxygen here must be -2. So the nitrogen here must be +2. Okay, oxidation numbers must add up to 0 for a molecule. How about copper nitrate here? We've already done the nitrate, so it's the same thing here. Nitrate. Okay, let's look at nitrate. Okay, each oxygen is how much? Oxidation number of -2 times 3, that's -6. So the nitrogen must be what? X plus -6 must be equal to -1. That's the overall charge. So what's the nitrogen here? +5. So if your polyatomic ion remains more or less intact during the reaction, then the oxidation number hasn't changed. So nitrogen here is still going to be +5. Each of the oxygen here will have an oxidation number of -2. So what's the oxidation number of copper here? How do you figure it out? You have copper combined with 2 nitrates. Each nitrate, remember, has a -1 charge. So what must be the charge of copper? Must be +2. Okay, so this copper right here is +2. And then finally water. What's oxidation number of oxygen here? -1. What's the oxidation number of hydrogen then? I'm sorry, -2 for oxygen. Hydrogen must be +1. When we say oxidation number, we do it on a per atom basis. Okay, so there's 2 hydrogens there. So the 2 hydrogens together is +2, so the hydrogen must be +1. Okay, given these oxidation numbers, remember what did we say about oxidation and reduction? Increase oxidation number, we say that element or that atom is oxidized. If the oxidation number goes down, we say it's reduced. So what is reduced in this reaction? Is it copper, hydrogen, nitrogen, or oxygen? Some more answers, 2 more clicks. So correct answer is, what's reduced? The nitrogen went from +5 here, okay, to +2 over here. So you say HNO3, okay, the nitrogen in HNO3 got reduced to NO. So that's reduction. Okay? The species that's involved in the reduction is HNO3, and the product of the reduction is NO. Now you might say, the nitrogen here is still +5. Then that tells you there must be some extra HNO3s where the nitrates did not get reduced, where the nitrogen did not get reduced. But this is the only source of nitrogen, so whatever gave you NO must have been an HNO3. Okay? So nitrogen, we say, is reduced. Correct answer is C. What is oxidized here? Your copper goes from 0 to +2. So you say copper went from 0 to +2. Okay? So, okay, you say copper nitrate. That would be oxidation. So your nitrogen went from a +5 oxidation state in HNO3 to a +2 in NO. That's reduction. Copper went from a 0 in copper metal to a +2 in copper nitrate. That's oxidation. Okay.